transport catapult time. So we're here at Digital Catapult, and I mean, we've had some enabling of innovation already presented to us, but the world is much bigger than construction. You know, transport's much wider. And Eifion Jenkins from Transport Catapult is here to talk to us about that. And I am going to put his presentation up. 3 minutes?
I'll give it a go. 2, no.
Eifion.
Okay, everybody still with me? Still awake? So I think I feel like I'm going to talk to you about a parallel universe to what we've been talking about, but something that needs to be certainly interfaced. Maybe we call it 5D, 6D, whatever we want to call it. But transport is very much needs to be a part of what we've been talking about and the environment, and needs to be stitched in. Okay, so my name's Eifion Jenkins. I work for the Transport Systems Catapult as the program director. And I'm going to talk to you about modelling for intelligent mobility, or perhaps alternatively named bringing models to life. It's probably more apt for what I've heard this evening. And we'll look at new tools and techniques for modelling and visualising transportation networks. So intelligent mobility, huge opportunity, an emerging £900 billion market by 2025, and a huge opportunity to create jobs and wealth for the UK. Transport Systems Catapult and others, we want to make sure that we secure a good chunk of that market for the UK. Mobility modelling, transport modelling is a key enabler to enabling us to get a share of that market. Modelling simulation helps us to inform decision-making around infrastructure, investment, services, and it's really important that we use modelling simulation to inform those decisions. However, there are gaps in the existing tools that we've got in the tool bag right now. We identified this a couple of years ago, and we've been looking at what we can do to support. My own personal experience, so I've had the privilege of working on a number of large projects. However, I've come across a number of similar pain barriers around data and data integration. So on the Olympia Route network, I was a design project manager, and it was a huge challenge to integrate all of the different modelling components that we needed to. I was just looking at the road down here. I don't know how we fit it in the games lane down this stretch. But we had to stitch a huge amount of transportation models, junction models. We had to gather all of that together and stitch it together, often by extracting from lots of different models and stitching it together in Excel tools, and then trying to calculate what the journey time reliability would be across the whole network, across 173 kilometres. It worked, but it wasn't easy, and I just kept thinking there must be an easier way. Similar with, I worked on the structures and tunnels portfolio, set up the BIM processes. I could set up an environment where I had the geotechnical information, the structural information, and so on. However, I had a separate transport modelling team where I couldn't actually integrate the operational, the systems into the environment. And I still don't think we can do that today. So there's an opportunity, a challenge there. In the transport world, there are a huge number of different transport models, at different levels, strategic models. We have models for pedestrians, we have models for highways and public transport networks. Some are at a very detailed level, some at a high level. And we're constantly trying to stitch these things together to get a holistic picture of what the system will look like. So we started to look at, okay, what are the barriers and what can we do about that? So we started to look at adjacent sectors. So we've looked at the gaming industry, scalable cloud computing, maturing very quickly at the moment. We looked at integration and defense simulation. For a long time, they've been using technology, high-level architecture, and it's got a standard wrapped around it. Couldn't we use that to help us with transportation modeling? And then we just started to look at performance as well, and high-performance computing, and how we can reduce the runtime of the models from, it currently takes 5 to 10 days to run models of cities. Why can't we just have that running in a minute? I just want to stress that we're developing methods that build on existing validated assets, so we're not reinventing the wheel. We're trying to enhance the capability. So I'm just going to quickly go through some of the technology we've been looking at. So I mentioned integration. So high-level architecture is a technology, IEEE standard, and it allows you to bolt different simulations together. So we've done a prototype which allows you to bolt the simulations together. So we can bolt a pedestrian simulator with a highway simulator, or we can have a number of different highway simulations, all transferring information between each other in real time. It also allows different entities to subscribe to the information as well, so we can bolt a Unity engine into the environment, and it can extract information off the information bus. So this is we've got a number of prototypes. This is a prototype which shows, see the red dots here, people leaving Milton Keynes Station, and that's been controlled by a pedestrian simulator, and it's been brought into a highway simulator. So as the people walk out into the road, the actual vehicles will interact with the people, so the vehicles will stop and let the people pass across, and then the cars will go again. So it's this integration of the simulations which is pioneering, and hopefully will create a lot of new value for reusing models. Keep moving quickly. Scalable computing. So we've partnered with Improbable, an SME based in London. So they've developed technology to create persistent virtual imaginary worlds. So worlds where multi-online games are played, where you enter them, and if you blow up a ship or you chop down a tree, it actually stays there until somebody else comes along and moves it. The world is always there. It's a persistent world. And then we started thinking, why can't we create a transport model in the same sort of way? Why can't we create a real virtual world? So we had a go. So we spent, with a period of about 3 months, we collaborated as a team and built, there's some images just down the bottom here, Manchester very quickly in 3D. We overlaid the highway network. We put some car following models in there, some basic traffic signal operations within there, and very quickly demonstrated that we can model at scale using this cloud computing technology. And we don't want to stop there either, so we're integrating the simulations now into virtual environments. So this is a facility that we have at the Transport Systems Catapult. It's a piece of hardware called an Omnifinity deck, combined with an Oculus Rift. And we've also got leap motion, so you can bring your hands into it. So we can now push the simulations through into these environments and actually experience the models. And an important point of this is actually selling the vision to key stakeholders, so they constantly got a feel for what's being modelled, how it will feel, how the simulation might say we can fit these number of people down a passageway or stand them along a platform, but how does that feel? What's the customer experience? So next steps, we're moving into the application stage of both the integration technology, high-level architecture, and the Living Cities demonstrator. We're looking for partners. We're really keen to collaborate, and certainly from what I've seen today, there's key opportunities where I'd certainly like to connect and figure out a way of how we can start bolting what I refer to as a parallel universe into what's been talked about today in the BIM environment. And also we're looking, as many people have mentioned, enhancing the visualization capability that we currently have. Thought I'd leave you with some questions that we've been thinking about, all about integration. So shouldn't mobility be a key component of the BIM environment? How do we achieve that? Who will host and control all of the BIM assets over time? So obviously I can see a lot of that going on. How do we manage that? I don't have the answer, but it's certainly something that we need to think about as all these digital assets are developed. Yeah, so thank you for your time, and hopefully there's some interesting questions.